Hello, hello. This time I'm going to do a video that's slightly different. I've been thinking of doing a new series of in-depth 3D modeling tutorials with Rhino and wondered how to make it a little bit more interesting, both for me and for the viewer, for you guys. Just 3D modeling from scratch is cool and all, but I wanted some sort of a base, some sort of a foundation geometry to model on top of. So I bought this Gundam model kit and will be 3D modeling additions to it in my future tutorials. But how do we get the cool robot into our 3D modeling program, you ask? Well, this is where Photogrammetry comes in. For those of you who don't know what Photogrammetry is, let me kind of oversimplify it. Basically, you take a bunch of photos, right, of some sort of a form, right, and then you feed those photos to a program, and by finding similarities between the pictures you took, it rebuilds the 3D form. So it's kind of simple, right? But it's actually not. But we'll not worry about the proper position triangulation and different point cloud sorting and filtering methods and so on, because we are not a bunch of nerds here, are we? Instead, we'll go through 4 of the most popular free apps out there, and I will compare them, not just their performance, but also how easy it is to use them and how cool the UI looks. I prefer to feel like I'm driving a spaceship, rather than a 90s Honda Civic. Before we begin, though, it's very important to note that I didn't just take the model as it is, because the plastic was reflective of the model. I actually sprayed it with some paint primer, and also I placed some registration points on top of different surfaces. This just helped me get much better chance at capturing all of the details of the model. Okay, so with that out of the way, actually let's jump to the first contender that we have, and it's actually a phone app. I believe it's for Android, it might be for iPhone as well. It's called Display.Land, and you can just, it's free to download. So using it is quite simple. You just click on the plus sign, right, to start a new recording, and you just move your camera around the object until it basically just tells you that you have the minimum required amount of frames captured, right? So this is just me moving the camera around and making sure that I catch at least enough, good enough amount of points. And it's really simple, it's basically like just filming your object from different angles. And then once you're done, you just give it a title, and it's going to calculate it on their own servers, right? So it's not going to be done through your phone. But the output that you get, it's this kind of a single OBJ file that you get, right? You just basically receive a link and you just copy it to yourself. You open up the link in your on your browser, and you just download the OBJ file. And let's take a look at how it actually looks like. I haven't actually seen it. I can already tell that it's pretty poor. Let's go for shaded view. Where's our, There's our model. As you can see, orientation is off, but that's usually the case with photogrammetry software. That's fine, that's easy to fix. That's how our model looks like, and let's see it with textures. Arctic. So that's how it looks like with textures. A little bit better, but definitely nothing spectacular. Very low resolution, but very, very easy to use. Okay, so let's actually move on to the next next program. So this one is called MeshRoom, and it's for Windows machines and Linux machines. And it's also, of course, free to use, as every program that we're going to be looking at today. The user interface, of course, since this is for for a PC, the user interface is much more clear. There's much more stuff to do here, but the basic principles of using this one is just dropping in your image files, and I believe I have them somewhere. Oh my god, where do I have them? Photogrammetry. Sorry about that. There we go. So I have my image set here, and I can just drop in all of the images and then just hit the start button. So actually, let me show you how it works, and I will just open up just a few, kind of drag and drop in just a few images from this list. It's going to extract all of the information from them and so on, and basically we can just investigate some images and see if we have any blurry ones, which is great. Just oh, the resolution is not that great of this one. I just used my phone camera to take these pictures. And then it starts going through series of tasks to give you the final result. And I will not be pressing the start button here, but if you press the start button, it basically will go through all of these nodes, right? Those of you who know Grasshopper know what these do, but it's basically going to go through all of these nodes, and by the end of it all, you will get both a point cloud and a mesh. And actually, let me discard that. Let me just find, there we go. I have a test one that I've already did. Let's just wait for it to open up. There we go. Right, so as you can see, every node here is green, meaning that after I pressed the start button, it went through this chain of tasks, right? So it did find all of the pairs. It's upside down, but doesn't matter. It did find all of the pairs of the pictures, and it kind of triangulated where the camera was. In which position was the camera once the pictures were took, and thus it created this point cloud for me, just from a set of pictures. And can I rotate around it? There we go. So it created a point cloud, and it's basically this. Let me just around here. Like around this node is where the point cloud kind of happens, right? And on the right hand side, you can see some settings that you can kind of not necessarily change, but these are just user experience improvements, so to say. You can change the size of the points, yay, and you can change the size of the cameras, also yay, doesn't matter. And you can hide or preview the point cloud that you have here. If you have a few point clouds, it starts making sense. And after this node, right, after the point cloud was generated, it generates a mesh from it, and then it kind of filters it out and wraps it in a texture. To actually, and you can see that this is also calculated because we have that green line here. To actually see the mesh, you need to press this load model button here. So you click on the load model, and it's going to think about it for a bit, and it's going to see texturing for a second. Let's just give it some time. As it's doing that, I could explain a few. Oh, never mind, it did that. I will explain those things in a bit. So here we have a textured mesh, right? And we still can't see it. Wait. We can't see it because it's a apparently lagging out. Recording while using photogrammetry software is not great. So you end up with this, and the points are in the way, so I'll just disable the preview of the points, and this is the mesh that we get, right? Actually, like 2 pieces of the mesh. And all of the surrounding stuff, which we don't really care about. So the resolution is not great, especially, or rather it's good, but it does kind of lack some details compared to what we had from Display.Land, like the previous app. This is much better. Here in the bottom left corner, I can choose to enable a wireframe view and actually see, you know, all of the polygons here. So this is much more resolution than what we had before. To export the mesh though, we need to right click on the, was it texturing, meshing? Doesn't matter. I'll right click on the texturing node, this one right here, and choose to open folder. Right click, open folder. Hello? There we go. And it opens up this folder for me with a bunch of different things. Some of them I care about, some of them I don't. Log, statistics, and status, I don't really care about these 3. Textures, actually 3, even 3 elements or 3 files for textures. Those I might need, you know, if I want to have any textures, like textures like these. So I will be keeping them. And where's the rest? And then we have the material, MTL. So this is basically just ties the textures to the model. And then we have the 3D model itself, 62 megabytes. Super. I will take this OBJ file and actually, I would just copy it to the desktop or somewhere just to keep it safe. But right now I'll just drag it into my Rhino window. Drag and drop import file. Hit OK. Let's wait for this to do its magic. And then here, as you can see, you can save the MeshRoom file as well. And to change options on how this program works with those point clouds and how it interpolates between the cameras, you can do that for sure. Every node here is basically an action, and every action has like a way on how to change, like a set of options, right? So for instance, image matching doesn't really have any options, so that was a bad one. But feature matching, this one right here, has options. So for instance, what kind of describer type do you use? And as you can already probably tell, these go pretty deep, and it's really hard to know what you're, you know, if it's good, what you're changing or not. So I would encourage you, you know, if you want to go deep into it, start reading and read a lot about it. Basically, the only thing that I would probably suggest you change if you want more resolution is under depth map, choose downscale to be 1 instead of 2. That's it. Nothing else. It basically will just generate more points. But the thing is that even with the default values, Display.Land took around 30 minutes to calculate. This one took 6 hours with 250 photos. Right? 6 hours on my laptop. So that's a long time. If I were to downscale it to 1 rather than 2, it would take 4 times longer. So it would be a whole day, right, of calculation time with more resolution, of course. So that's MeshRoom. Now let's close it. discard, and I have that mesh here. Actually, let me just rotate it in place. I just kind of want it to be in correct, to have a correct height, not height, sorry, orientation. And I will just move it down here to the right, scale it down a bit so that it's kind of a similar size to the Display.Land mesh, and place it side by side. So now we can take a look at both of these by just right-clicking, choosing for, let's go for Arctic view now. Okay, this is completely messed up. I will need to investigate this one. Why is this messed up? Well, it doesn't really matter, but because we don't care about the texture, but the texture kind of fell apart. That's not a problem. Let's go to display, and for now I'll just choose to not show mesh wires so that it's easier to see. So this is what kind of mesh we get from oh right, that's because I joined it up. I joined up the mesh, so it messed up. Whoops, sorry. Anyway, much higher resolution mesh than this bad boy right here. So we're getting there, right? Let's see what else we have. So right now we have two of them, and the next app, the next software is called Regard 3D, and as you can see, it loads up really fast. It doesn't look that fancy as the other ones, but I have high hopes for it. So the way you work with it is you basically just create a new project and you just call it whatever. I'll just call it QQQ. It automatically will save a R3D file. Okay, so I just save it. Then we have project QQQ, right? And it asks us to again add a picture set. So I click on add picture set, I choose add files, and I still don't remember where I put them. I believe they are right here. And I'll just add like, let's go for like 10 files. That is probably not 10 files, but it doesn't matter, right? I can give it a name, QQQW, whatever, hit OK. And it's always, I don't know why, but it always tells me the focal length is known for too few pictures, even when I give it like 250 pictures. It seems to work with this, not error, but warning, so I don't care. I just hit OK. And I have a picture set, QQQW, with 34 pictures. Okay, that's fine. And then the way you work with it is you just kind of click on the buttons which you think should be the next step to take, right? So you have a set of pictures. You choose to compute matches, right? You need to match up the pictures. And here you can change the sensitivity and so on, but I really suggest that first you just choose the default values just to kind of get a hang of it, right? Because the quality of the picture, the consistency of the lighting, and not having blurry pictures makes much more impact on the final geometry rather than the settings. That's for sure. So now it's computing the matches. As you can see, it's taking a while. It's going to, oh, the output window is not here. So I'm going to pause the video for a bit, and we will continue once it's done computing the matches. So there we go. It's done calculating the matches. It did it in 6 minutes. I believe, yeah, it did it in 6 minutes. I hit OK, and then I can see that on the left-hand side, these icons or these buttons changed, right? Because right now I already have matches calculated, so I can have more, I can move forward with these kind of steps. So I can show matching results, and here I can kind of just, it will open up this menu where I actually can see the matches found between different images, right? And between different image sets, which is pretty cool. But the main thing about it that I want to do is this triangulation, right? So I want to like construct a 3D point cloud from these matches. And here, at this point, I should probably start showing you an already finished result, because this is going to take a little bit of time. But just while we're here, triangulation parameters, you shouldn't mess around with this too much, but basically to create a triangulation, it needs to have a pair of photos, right, that it finds to be this kind of, that it's going to use as a reference, as a baseline, right? And it's going to kind of keep adding information onto that pair of photos. So I always just use image pair with highest matches, right? Where you have the highest amount of matching points into images, that should be your baseline. Then you just hit OK and it kind of calculates. But let me actually open a project rather than show you an existing one, show you a new one. And I'm trying to remember where I had it. I believe it's this one. I'll hit open and we'll see. So you can see here that I uploaded a picture set with 260 pictures, right? I calculated the matches and I have no idea what this means. Then I clicked on the triangulation tab and this, it doesn't show. Why doesn't it show? Show triangulated points. There we go. So it kind of generated these points for me. Okay. And then I used create dense point cloud, which basically just densifies this existing point cloud. So densification, again, show point cloud. So you can see again, this works in steps. These are still points. If I were to zoom in, you can see that these are points, but this is a very dense, very, very dense point cloud, right? And then I created a surface with default values, and this is how it looked like. And I wasn't happy, right? So I created a new one with a higher density. Let's wait for it. Come on. And I'll show you, of course, how to increase the density of the surface. So this is how it looked like. There we go. As you can see, the textures are complete garbage, but or rather, there's no textures here, are there? There. Fill line point. Yeah, whatever. I will not start playing around with it. Because here the colorization type is chosen to be colored vertices rather than a texture slapped on top of the geometry. So of course it's not going to be that nice. But notice where before in MeshRoom we didn't have the center part here, and here it rebuilt the center part really, really well. So I'm happy with this result. And then we have the third surface, but I will not even show you it, because way too many samples. So how do you increase the amount of samples? Well, or rather amount of points from something like this, or rather from show surface, from something like this to something like what we saw before. because both of these surfaces, they are created with the same point cloud, right? From the same point cloud, meaning it's this densification setting it's here where we need to change some sort of a setting to make it better, right? So to make it better, when I click on the densification and I click on create surface, here I have a shit ton of these kind of things to like pulls and levers and buttons to change. There's only one that we are interested in, or rather maybe two. First one is the depth. The larger this number, the more vertices, more points are going to be used and created, right, for a mesh. So the denser the mesh is going to be. I'm not showing you surface 2 because I used the depth of 18. Oh, no, sorry. I used depth of 14 on it. So surface 0, the blobby boy, is depth 9, exactly this one. Surface 1 is depth 12, and surface 2, the highest density one, is depth 14. And depth 14 is, I believe it was, when I exported it, it was 1.6 gigabytes, right? So be very careful. This is an exponential, the vertex count increases exponentially. And then we have a colorization method here where we can choose either colored vertices or textures. In this case, I just colored the vertices. I really don't care about the texture. But if you want to have a nice texture, then you just choose textures here. Okay, so when I have the surface that I like, I can just choose to export surface. I choose OBJ, save it, and call it a day. And I believe I already have it saved, so let us find it. I believe it is going to be right here. File. That's picture set in, no. Those are definitely not the ones that I need. Crap, sorry. Let me quickly find. There they are, sorry. So I have one that's 1.6 gigabytes and the other one that's like half a gigabyte. So I'll choose the smaller one because we don't want to deal with that amount of information. Still, half a gigabyte is pretty damn large. So I just drag and drop it in. There we go. It loads in really large, but that's fine. We will fix it. And it's also really, really heavy. So that's another thing, right? When you have these kind of extremely large meshes, Rhino is a bad, like you're gonna have a bad time with Rhino. And where the hell is my, oh, it's upside down. So you will have a very bad time with Rhino. It's much better to clean it up first in like in Blender or something like that, and then continue on working with it in Rhino. And actually, just for comparison, I will probably do that. Yeah, I will do that. So give me a second, and we're back. So here's how they look like after I've cleaned them up a little bit in Blender. And don't worry about it, I will be doing a separate tutorial video on how to slightly kind of remove the unnecessary bits in Blender. But basically here we have the Display.Land mesh, here we have the MeshRooms mesh, and here we have the Regard 3Ds mesh, which is a little bit wonky as well. Right, and of course you can already tell which one is the heaviest, but I just wanted to show you kind of visually the differences between them. So now we are going to actually move forward to our last contender, which is going to be Autodesk's recap program. And the thing is that Recap is not necessarily a free program, but it is free for educational use, right? So as long as you're a student or a faculty teacher, it is going to be free for you. And there are certain restrictions that come with it. So let me open it up real fast. Wherever I have it, there we go. Recap. And as you can see, there's the first problem. The user interface is very, very small because I'm running a 4K screen, and Autodesk for some reason they didn't bother to fix the scaling for laptops which are running 4K screen. So it's a very, very small user interface. And barely usable. We will so that's why I'm just going to really quickly go through the settings here and call it a day with this program, because I believe it's, borderline unusable on my computer. So to start off, I will go to create 3D here in the top left, and I'll choose object. And here it's just asking me to give it a set of images. And now notice one thing. If I give it all of my images that I have, right, 260, and I hit create, it's going to say project creation is limited to 100 photos, right? So I can only give it 100 photos, which really, really sucks. And honestly, I have no idea how to get out of here. Can I just please let me out? No? Can I close this? Cancel this project? Yes? Okay. So that's the first restriction. As long as you're in educational use, you can only have 100 photos, which depends on what you're trying to do. Sometimes it's good enough, but for a model as intricate as this one, I believe we do need a little bit more than 100 photos, but still I tested it out. So I had two tests done. First test was done here with, can I load it in? Oh my God, desktop. Yeah, just desktop, doesn't matter. Just give me. Oop. There we go. So the first test that I've done was without the primer on my just the red robot, right? Robot model, and this is how it looks like, right? So you can see a foot here and a knee here, but most of it is just completely broken. That's a head. And it broke so heavily because the plastic was reflective, and everything that is reflective will break apart horribly, right? So I couldn't use it. That's why we did it with the primer and the registration marks. So now we can actually look at this guy right here, right? This is what I got from 100 photos, right? Seems to be kind of okay. At least the texture is, oh, never mind. The texture is a little bit messed up, but the 3D model seems to be a-okay. And by the way, the way this particular software works is it doesn't calculate it on your computer. Rather, it uploads all of your photos to the Autodesk server, where you need to wait for it to start calculating. So the server calculates it for you, very similar to how Display.Land works, only that for Autodesk there's a queue, right? A waiting queue. And then in like 2 hours or so, it kind of processes your 3D model and lets you kind of download it back from the server. So this is what we're looking at right now. And it's quite intuitive. The problem is that the menu is complete garbage, right? So that's the model that we have, and to export it, all you need to do is just click on this export button that you probably can't even see, and choose to export model, right? And here I just choose OBJ, hit export and call it a day, right? So now I will clean it up as well and upload it to Rhino, or import it to Rhino, and I'll show you a comparison of all 4 of these softwares, or the outputs of these softwares. And there it is, the 4th one and the last one from Autodesk Recap. So here we have all 4 of them, and let's just quickly go through them and just investigate what we have. So the first one was Display.Land, right? Mesh. This is nothing to talk about. It's just, you know, it is what it is. It's a phone app, nothing more than that. So it's not that great. Next one we have, I believe it's a mesh from MeshRoom, and while the mesh itself is a little bit lower resolution, and I believe this one took around 6 hours to calculate, compared to 2 hours here and 4 hours here. So it takes way too long for this kind of resolution. What it actually calculated is not that bad. You know, you can get the kind of the correct proportion and so on, and start modeling on top of it. Said that, I believe it's only the legs that I would consider to be good enough. Everything else is way too low resolution. So it's, when it comes down to MeshRoom, I would consider it if I had a much stronger computer. The one that I have is Dell XPS laptop, nothing fancy. So MeshRoom, kind of quality-wise, not that great. And then we have other 2, right? Regard 3D on the right and Autodesk Recap on the left. So Regard 3D did a great job, I think, right? It captured a lot of detail that was missing completely in the previous 2 versions. So it captured a lot of detail, but the problem is that it's quite noisy in the way it works, right? So there's a lot of inconsistencies and irregularities on the surface. So I would definitely be inclined to kind of remesh this and retopologize this to be able to work with it. Said that, I believe this is great. You know, this is really superb. And the cool thing about it is that since this is a symmetric piece, I can kind of grab some parts from the right hand side and mirror them to the left hand side and vice versa, right? So I can rebuild a lot of the mesh just simply because it's a symmetrical mesh. So Regard 3D, when it comes down to geometry itself, did a great job. A little bit even too great, I think. There's too much noise going on in the image. And then we have the last one, the Autodesk Recap, which also did quite well, considering that all 3 of previous ones used 250 images as a base set, and the Recap one only used 100. And also it was quite fast in the way, in how fast it calculated it. So you can see that we are missing quite a bit of information from the underneath of the sculpture, of the mesh, right? And that's because I needed to delete, more than half of the images. So I probably deleted too many from the bottom, with the camera looking upwards towards the armpits and the crotch area of this robot, right? So it couldn't rebuild that, but what it rebuilt, I would say it even did a better job. Wait. yeah, kind of, a close enough, pretty close, decent job compared to Regard 3D. I believe if I were to tweak Regard 3D, it would do a better job. It would come close to this the kind of surface quality, but I think it's just great to see, this kind of program work in the way it does with this amount of photos. So that's these 4 meshes. And one last check that I want to do is I want to change this to Arctic view, just to see if it transfers the images as well. Sorry, not the images, the textures as well. And apparently it does, except for Regard 3D, which, yeah, we didn't choose to save the texture, right? So it would have transferred, but so the texture transferring for recap is not great. It's not bad. I wouldn't consider it to be bad, but there's a lot of misalignment, so it's not great. In this case, I believe, yeah, well, just because Regard 3D mesh was kind of, is out of this race because I didn't save the texture. My bad. I believe MeshRoom takes the lead when it comes down to texture transferring. It's doing superbly. This is amazing. This is great. And then we have Display.Land. You tried, this kind of a Display.Land will get a medal. You tried. Okay, so we have these 4 meshes, and let's jump to final key points and final conclusions, right? So let's start off with Display.Land. The mesh that is being produced is very low quality, very low resolution. The program is extremely easy to use, but you cannot change any points, any settings, and it doesn't run on your laptop or on your computer. It just runs on your phone, which is both convenient and also a little bit kind of wonky. I'm not a phone person myself. I would suggest using this kind of program. Just it's like a toy, right? This kind of app is basically just a toy. Then we have MeshRoom. So MeshRoom is the output quality of it is pretty low. It was the slowest of all 4 of the tested ones, but it did produce the best textures, right? So was it easy to use, MeshRoom? Yeah, it was just literally a single button press and then just leaving the computer for 6 hours. So I would call that easy. Does it have any customization and settings? Yes, it does, but all of them are quite well hidden. And once you actually see them, you have no idea what they mean, right? So ease of use, I would say it's a kind of a wonky situation here. And for the use case, I would say MeshRoom could be considered a useful tool if you had a stronger computer, and I don't, right? So which brings us to Regard 3D. The quality of the output actually was the highest, right? At least the resolution was the highest, but the precision was only average, right? Ease of use, I wouldn't say that it was very poor, but it definitely was non-intuitive, and UI is not pretty, which is a big strike in my book. It does look dated. In regards to the settings, actually it maybe even gives you too many settings to choose from because you have no idea what half of those mean, but at least the settings are in your face and you don't really need to kind of dig for them and try to figure them out. And for the use case, I would say it's the best program when you need to make the image set that you already have just work, right? It gives you a lot of settings and you can play around with them. It is faster by 1/3, by 33%. It's faster than the MeshRoom. So this one is something to look into in the future. And then we have the last one, Autodesk Recap, which was amongst the decent ones. It was the fastest. It only took 2 hours, and of course that's because it wasn't my computer that was doing the calculation, but rather it was the Autodesk Cloud. The output quality was average, I would say. But average considering that we have that 100 photo limit. Ease of use, I wouldn't say that it was great. It was actually pretty damn bad because it tries to hide too many things and it tries to have this very minimalist UI. And some things are just, it's poor. It's not great. Customization wise and settings wise, again, it doesn't let you change anything. It's pretty poor. You can work with the mesh afterwards, after the photogrammetry has been done, but beforehand you don't have anything to choose from. So for the use case for Autodesk Recap, I would probably say this feels like more of a teaser for a pro version, right? This educational version is more like a teaser rather than a finished product. It's way too buggy, and I can only hope that the pro version is less buggy and actually doesn't limit you to 100 photos. So to conclude, for the next tutorial video, we are going to be using Regard 3D for this guy, right? And we will be scanning it. We will be modeling on top of it, creating some new cool forms and perhaps platforms, and we'll take a look at different tools that will help us with that. Right, so stay tuned for that. I'll see you all on Wednesday, I guess. Bye.